For presenting, I would like to tell that in this talk, like in this talk, I will deal Quasars in much more detail. However, for Pulsars and other subtopic, that is formation of stars, that is also very interesting. I will taking time. If I have a time, I will continue with that. However, if I don't get enough time, I will continue it some other day, and everyone will be updated. So Quasars and Pulsars, and one more thing I would like to say. Again, in every of my talk, I used to say this one fact time and again that it's important to understand the physics behind every phenomena or every development which is mentioned in any theories. But it is also very important to understand the fact that how these theories are being developed. Because at a point, we don't have anything. Like we don't have anything, but at another point, we have a very good convincing theory. So I would like to appreciate everyone the journey, that beautiful journey between nothing to everything. So here also I will focus on like making understand how the idea was developed of Quasars. So I think that is the my starting words. So coming to my first main slide, that is Quasars. So basically, the first thing which we ask about everything is that what is quasars? So basically, quasar is a very anomalous name. Actual name for quasars are the quasi-stellar radio source. So there is a good story, and which I will like to tell you all. So what happened? Like before 1950, the whole astronomical thing was based on the observational astronomy, and all the data which we were using was the optical data. Like we were getting a lot of data from the optical telescopes, and we used to analyze it. But what happened after 1950? We shifted from optical astronomy to radio astronomy, and that's where we did a lot of wonderful job. So everybody will be knowing about Winston probe, that where we were getting the microwave of the we were getting a lot of microwaves from the whole universe, and that is one of the very important discovery, that is background microwave radiation. I'm not going to talk about it right now, but that is very important and one of the remarkable discovery in the astrophysics and astronomy. So what happened once people found that okay, we can get a microwave throughout the universe, people started mapping the whole universe from the radio signals which they were getting. So what happened? There were two scientists. As I'm very bad with the names, so I'm not going to take the names of any scientists. But I recommend you to later on go and visit the names and do your needfuls. There were two scientists who were trying to map the universe. So map in the universe means they were at that time the universe were divided. All the objects in the universe were divided as a hot source object and common source object. Hot source object were something which were emitting radio signals at a very high range and with higher energy. Another was which were emitting radio signals at a very lower rate or with a lower energy also. So what happened? These two scientists were doing the same job. So what happened? They found in the universe, they found the patches, like a small region, very small pinpoint region in the universe, where a lot amount of this radio signals were coming enormously. Like enormously in the sense, they had no idea that, okay, there should be any source of radio signal. So their antenna just moved to one region of the universe and they could find a lot of radio signals from that region. And then it was a blank for a time. And again, they were getting, so the radio signals were very random and very limited in the number. So this created a curiosity. What is this radio signal is all about? So when they could find this radio signal, now what they tried off, locating it, that radio signals through the optical telescopes. So what they did, they focused their optical telescope to the exactly the same source from where they were getting this radio signals. But this source was so mysterious that this optical telescope of at that time couldn't locate them. So they were just blank. And then, as I told you, it was first discovered. This radio astronomy basically begins in 1950s, but and it took 10 years to discover these source. I was telling this quasars in few slides as a quasi-stellar radio source because quasars was not official name of that time. It came much later in 2002, I guess. So earlier they were known as a quasi-stellar radio source. So these optical telescopes were not about to locate this. What is the source? They were not about to find the optical counterpart of this radio source. So, but they were finding the this optical counterpart of another is objects like stars, nebulae, galaxies. Since they are also emitting these radio signals, so they were easily able to find the optical counterpart, but they were not able to find this optical counterpart for these small sources. So, detect another thing is detected radio source without optical counterpart appearing as an unresolved point source. So it was last time it was unresolved point source. So what happened when they were like not able to find it? They further tried to investigate these source. And what were the investigation is that we will taking as an early background of quasars. So what is the idea from where the quasars is developed? We will talk. So, first thing, as I told, that a small number of anomalous objects with the properties that defy explanations. So, earlier it was found as a very small object, and their properties were as such. No, it can't be hardly defined. Like we didn't have any current explanation of what we are observing and what properties which we are talking about. So first, the major properties which we are talking about that is the spectral line. So I hope that everyone know what is a spectral line. If not, I will say like I will just give the verbal definition of my understanding of the spectral line. So what happened like when the like if we try to understand the spectral line in the terms of optical waves, like the optical waves in the sense the like light source coming from that. So we know that the lines are the signatures. So when this light source passes through any medium, some of these light beams get absorbed and some of them get emitted. So we used to get certain lines, and that line is taken as a fingerprint or specific signature of that object from which that light source is emitting. So when the astronomers of that time tried to analyze the spectral lines, so as you can see in this first image, these were the spectral line source which we are getting from the quasars. That source, I should not use the word quasar as of now because quasar word was not into existence at that time. So this is they get this spectral line from the for the sources which we are having at that time. And just below, you can see the spectral line variation for the normal star or galaxy. So you can see very difference, right? This is where they were very strange spectral lines. However, we expected such kind of spectral line of that time. So this was another mystery. And another thing what they found that luminosity changing very rapidly in optical range. However, when they later on they developed some advanced telescopes and they again focused it there, all they can see is very tiny dot, and it was immensely bright. That quasars were after development of some advanced telescopes, and when they were focused at the same region from where they were receiving this signal sources, this radio wave sources or whatever the sources of it, they found that the luminosity is luminosity of the source is changing very rapidly. So again, created a lot of speculation. What is that? So there is another story. At that time, two scientists, there was a group of scientists. They claimed that this is the antenna source for the aliens. So they claim that the aliens are talking through certain signals, and we are catching that radio signals. And they were finding that okay, we might be receiving the alien source from so the signals from certain aliens or something like that. But it was not true, and we found it later on. So now what we had like after this optical counterpart was seen, like by using certain advanced telescope. Here in the right side, you can see two images which were captured by Hubble telescope. We know that it is one of the very famous Hubble telescope, that is Hubble telescope. When Hubble telescope captured these radio sources, they saw something like a very teeny dot, extremely bright, extremely glaring. And in other image, you can see chronograph image of the same quasar object, which you can use chronograph image to eradicate all those glaring effect and something like that. So you can figure out that these were very teeny source, very teeny, very minute, very bright source they were. Now, what happened again? As I told, the spectral line what we had received was very bizarre, like it was not seen from any of them. However, this there was one good gentleman, that is Ischemic, or how you pronounce it, you can pronounce. I am very bad at pronunciation, so you can pronounce it. For me, he is Ischemic. So this guy, what did he further analyzed all these spectral lines? So and he gave this his discovery that these spectral lines, what we are receiving from the tiny dots, that is quasars, or that quasis stellar radio source, there is nothing but they are thus hydrogen lines which is red shifted by 15.8%. Now I know this red shifted and blue shifted might be troublesome for you. Like I understand, but I will just deal with a teeny mini, like I will just spend very tiny part of it, what is redshift and what is blue shift. So we know in our practical life, we are very well aware with Doppler effect, right? So Doppler effect means when something is coming toward me, the frequency will be increasing, and when something is going away from me, the frequency will be decreasing. So the same way, when we talk about the astronomical object, so when some object is going away from us, this is the very basic idea I'm telling. So if something is going away from us, so its frequency will be again decrease as in a Doppler effect. And if something is coming toward it, its frequency will be increased. So if frequency is decreasing, it will be red shifted, and if frequency is increasing, it will be blue shifted. So he found that the spectral lines which I showed you in the previous slide, it was nothing but the spectral lines of the hydrogen, which is red shifted 15.8%. And again, as I told, when the optical telescopes were focused in this region, they were seen as a very small sized object, and there was nothing very small dots in the very small dot in the night sky. So again, this created a lot of speculation why there is left shift and what is why there is a this all this they are so small and all. So which we deal with in the next slide. So now I will understand. Okay, we had certain early observations as I talked, that is rate shifted. They are very small size. So now what they imply, what we can understand, or what earlier scientists were understand. So first they were what they focus. They focus on trying to find what could be the possible reasons for the redshift. So they came up with there were two groups of scientists. These two group of scientists came with the two possible reasons. So one was very obvious, that is maybe this redshift they are able to observe because certain kind of the physical motion. And physical motion in the sense, as I told in the Doppler effect, a certain object is going away, the frequency will be decreasing. And if the frequency is decreasing, we will observe the redshift. So if that is true, if my this implication is true that we are observing this redshift because of the motion, so it means that 3C273, actually this 3C273 is nothing else, but it's just the name of that quasi-stellar source which were discovered back that time. So this 3C273 was receding at an enormous velocity. Now, and that velocity was found to be 47,000 kilometers per second. However, we can work out, if anybody want to work out, we can still work out, and I will further work out this how they got this velocity in the group. So it's nothing but suppose I will again explain from the Doppler effect. Like in Doppler effect, if we found what is the change in the frequency, and what is the velocity of light. So you can easily equate and find the equation what is the velocity of the source object which is moving at. So they found that this source was nearly moving with a 47,000 kilometer per second, and which was far beyond the speed of any known stars and defying any obvious inflammation. So there are many stars which we found at till that time. Since this velocity was so huge that there is no any stars was in the range of this velocity. And if there was no stars, so there were no explanations. So we didn't have any exact reason why we are observing this. So another reason which can be is due to some cosmological reason. Due to cosmological reason means we don't know what exactly that reason is, or it may be certain like a certain way of functioning of this universe, and that's why we are getting. So it was very arbitrary at that time, but later on it was found to be correct. Um, and this cosmological reason, if we take this cosmological reason to be correct, then we had another further implication that this must be very luminous than any galaxies, but much more compact. Since it was a very small in the size and very bright, so we came with conclusion, okay, if we are getting to see this certain kind of, it must be very bright, and it must be also, very compact or very small in size. So there was another implication if I say that the object is moving because of any physical motion. What was that implication? So if we apply this reason that we are getting that redshift because of the motion, so we mean that rather than being a star in our galaxy, it means that rather than that star to present in galaxy, it should be present very far away. And how we can come into this conclusion? We can come in this conclusion with the Hubble's law, because Hubble's law, we know that recessional velocity is directly proportional to distance from where you are observing. So the more the further object will be, the most fast it will be moving away from it. So as I told that this velocity is so huge, that is some 47,000 kilometers per second. So it implies that the object must be very much away from the our galaxy, and the distance you can directly again find it from the Hubble's law. The distance was found as something 4 billion light years away. So this object, the source from which I was we were receiving this radio star, it should be very far away. That is 4 billion light year away. And this again, this was very challenging to accept. Why it was very challenging to accept? Because it challenged our understanding. It challenged two things. Earlier, what we had this during this 1950, we had the idea of this static universe. A static universe in the sense we were not expecting that universe is something which is moving or which is expanding. We were saying, okay, this universe is expanding. So first thing what it did, if we imply this Hubble law on this radio source object, so it ruled out the possibility of this static universe, because it changed the distance to very large at a very large scale, and that's why it's very very difficult to understand why this there is so much distance. And it was the one of the furthest seen object in the universe. Like like if I see what is the furthest seen object, if I have humanity have ever found in the universe, so it must be Quasar. So it increased the as I told the astronomer council, the size of universe increased suddenly dramatically. So this whole idea of what should be the size of universe increased very suddenly and very abruptly, just because of this quasar particles, or what you call them, this quasi-stellar objects. So now we have some. I just spoke on the implications. Now, what is the development of physical understanding? So now we will logically assess every implications, and we will try to rule out if there is a thing. If we will try to rule out if there is something which doesn't fit in our physical understanding. So what first thing I told is this redshift is caused by because of the motion, that the physical motion, or that basically is special relativity. So if I say that this redshift is caused by object moving, then what can be further understanding which we can see? So if we say that it is caused by first reason, that was because of the physical motion, then it implies a very distant object with a extraordinarily high luminosity in order to send large radio signals. So if I say that it is moving and it is very far away, so I am say I in my current equations are, or my understanding of the physics says me these objects should be very luminous because they are getting very strong radio signals, very large amount of radio signals. So it says that these objects are very strong, or they are sending very strong signals. So it means that they must be very luminous. That's why they can send such a strong radio signals. Another is if immense power output. And again, as I told, when the optical telescopes were focused in that region, so they found it very small as well as very bright. So there is to condition that it should be very immense power output of that quasi stellar object, and which is far beyond any seen object. So this again it was very tough to understand, and it was again it came with certain bizarre conditions. That my first condition that this redshift is caused because of any physical reason. If I accept this idea, or if I buy this idea, I have to accept these two facts which were very bizarre and very unknown at that time. So, and that's why we can understand these things are very improbable to talk about. Very improbable means very abstract without any mathematical understanding or anything. So this idea of that they are moving with a very high speed and very at a very distance object, and that idea was rejected and was not widely accepted at that time. So now what I came with. So now, what I am saying, I am altering. I am saying that if they were very small and much closer to a galaxy, so I am cutting out. Okay, I am giving another idea to buy. So I am saying, okay, fine. They are not a very distant object. So I am saying they are closer to our galaxy. So in first I talked, okay, somehow I am defining this Hubble's law. Somehow I am defining all of my earlier physical understanding. I am creating a new clause. Okay, if they are very small and much closer to the galaxy, then I could be easily explain the apparent power output. So I can explain the second point by assuming that immense power output by taking it a very small and closer to our galaxy. Then again, I will fail because then I can't explain redshift and lack of detectable movement against the background of the universe. So then again, I can't explain the redshift if I say okay they are very close to us in our galaxy, then it will be very difficult to explain that why we are observing the redshift. So and again we were not having any movement against background of the universe. So if we are observing this quasar particle in the background of the whole universe by taking it as a rest and this quasar's object in motion, so we will not be able to explain that this movement which we are observing through the optical telescope. So definitely we knew certain new mechanism which incorporate every observational results which we found. So what that observational mechanism or new mechanism, what is all about. So that brings us to very interesting topic, that is Quasar engines. So Quasar engines, this quasar is a extraordinary energy output demanded and extraordinary source. So we know that power output, like how from where this stream power is coming and why the object is so bright, so small. So this all need to be explained. So for this, all these extraordinary problems, all this extraordinary energy demand became with an extraordinary source, that is black hole. So further, I would like to tell about the timeline. So all this discussion was happening during 1960s to 1970s. And that time, the idea of black hole was very theoretical. No one was ready to believe that, okay, there is something like black hole can exist in the universe. At that time, very few scientists were buying this idea of the black hole. So again, it is same thing like relativity. As we know that when relativity came, very less people were ready to buy that. Okay, time is also variable, space is also variable, everything variable, nothing is fixed. There are very less amount of people who are ready to buy this idea, or it is like something quantum mechanics. Very less amount of people who are ready to buy the idea of quantum mechanics, right? Similarly, at that time, very less people were ready to buy the idea of the black hole to explain the quasar object or those quasi-stellar object. So, in this regard, this quasar is very important because it gave us first insight to the black hole, or first, you can say, first observational proof to the this black hole. Because by using the concept of black holes, we were further explained to what is quasar actually. So we will talk about this quasar engine. What is this quasar engine is all about? So let me have my drink water. Sir. So now what I did, I told that this powerful this stream brightness, stream power, and this redshift, all this can be explained if we are ready to buy the idea of the this black hole. So it was proposed that a black hole could be a powerful energy source by asserting gas from nearby stars. So we all know that when stars, it was again find there was one very concrete proof of this idea. Further, it was found that through the optical telescope, further it was found that all these causes were existing between some galaxies, and that later on it was found that that happens to be center of the galaxies. So from this we came to conclusion, okay, there is a black hole present in between or center of every galaxies. So it was proposed that black holes could be powerful energy source by emitting gas from nearby star. So we all know that if there is a black hole in the center of the galaxy, suppose this is center of my galaxy, this region. Just suppose it, I'm trying to show it on my screen. Suppose this is a black hole, and this is my whole screen. This is whole. This is a galaxy. So, and this white region which you are seeing, they are the stellar dust, and these two things are the stars which you can see. This is also a star. This is a star, and this is a black hole, and this white thing is a stellar dust. So, what the idea I'm saying you to buy this stream energy, since this all this stellar dust will be attracted to this black hole, and they will start revolving in a certain form in a circular motion around this black hole. And while they will be revolving, they will create a plate or disk that is known as asserting disk or assertion disk, whatever you call this, or simply you can call it disk of black hole. So that will create a disk because all these gaseous atoms will be strongly pulled by this black hole, but they will not fall into the black hole at initially. They will first start asserting around this. So what happens when the gas is revolving around this black hole? So because the gas would be spin around the black hole in a high velocity orbit, it would be heated to high temperature, causing it to radiate. So now I am saying, since the gas is revolving very high with a very high speed around this black hole, it will heat it up to very high temperature. And once it is very heated to very high temperature, we all know that black body radiation concept. We have studied about the black body radiation. So it will start radiating. So that radiating will be receiving in the form of a radio ray, and we say that is the source of the radiation which we are getting. And what will happen? It will not just stop here. There will be friction about in the gas also, and which will be there will be friction in the gas, and due to the friction, the gaseous molecules will lose their energy, and since they will lose their energy, they will end up falling into the black holes. But when they will end up falling into the black holes, they will emit very high energy radiation before it disperses, and that's why we are getting so bright, very high power output. So I hope it is very clear to all of you. I will just repeat this. What is all this Quasar engine idea is? So Quasar engine's idea is that this Quasar is not something a different object. It is just your assertion disk of the black hole. This Quasars, what I am telling of this Quasar as something or something as a very different object. Later I am saying you this Quasar is not something like a star or something like a galaxy or something like that. It's just that something which is revolving around the gaseous molecules, stellar dust, which is revolving around the black holes. If this is my black hole, so they are revolving around this black hole in a continuous direction, and because of this continuous revolution, they are getting too much heated, and because of the extensive heat, they are radiating. And since there is also friction in the gaseous molecules, so somehow some of these gases molecules are losing their energy and they are finally falling into the black hole. And this falling procedure is needing a lot of energy output, and that's why we are saying it very bright. So this idea of the Quasar engine helped me to understand the two things: why it is very bright, why we are getting lot of this radio signals. But again, we had to further explain the concept of redshift. Again, I didn't address the what is the if and one more a very beautiful thing happened. So if we are ready to buy this idea of Quasar engine, then we can accept it that these Quasars are not something which exist very away from us. It can exist near to us, or it can exist near to us. I'm not saying my next door. Near to us in the sense it can exist in our galaxy. It can exist in any nearby galaxy or something like that. So this idea of Quasar engine removed the distance limit. Earlier it was like this would be very away, like 2 billion 2 billion light years or something like that. So when I took the idea of the Quasar engines, so this thing the distance problem was sorted out for us, but still there was problem of the redshift. But again, that is very interestingly and very beautifully solved by Einstein's general relativity, which I am going to deal with in this slide. But be in mind, as of now, I am not dealing with general relativity. I will just give you the overview, or you can say I can take it as a direct application of general relativity in order to explain the redshift, which I was discussing was a lot more problem for the scientists at that of with idea. So here first I will talk about this picture which is present in my screen. So this picture of the week shows a huge cloud. As I told, there are like lot of stellar dust gas around it, and here you can see a very bright object, right? So this is basically a quasar, and this is a basically a quasar. And if you go to the chronograph image of this, you will find the black hole at the center, and this stellar dust image or this stellar gas, they are being attracted by it, and that's what we are getting this quasar idea of all this. And this was captured by multi-unit spectroscopic explorer, that is MUSE, and that is very large regard, and that is located at a Parnell Observatory. This is the official image released by Parnell Observatory, which is in USA. So you can see that this thing is later on it was found that this quasar source or this black hole was in present of center of the galaxy. So it gave me two idea that there is a presence of black hole in the center of galaxy, and these quasars are nothing but the disk of these black holes, and they are emitting a lot of lights and a lot of radiation because they are eating up all this stellar dust, and they are making it revolve around these black holes, and in the process they are liberating a lot of amount of energy and radiations. So now, but black hole would not have an unlimited fuel supply, and that dead quasars could be common in nearby galaxies. So again, I came with one problem, and that problem is we all know that what is actually these quasars objects are. They are the just stellar dust revolving around the black hole. So we know that stellar dust can't be something unlimited or something infinite or something like that. They must be coming in a very small, not very small, but in a limited amount. So, and with the time they will be getting used. So if all the stellar dust around the black hole got used, so that will lead to the dead quasars, because they will not furthermore liberate a lot amount of energy as well as the radiation. So that is the thing that, and I will further imply this point to understand how we can understand early universe. That is in this slide I will talk about. But this redshift. So the idea of the redshift, which was very troublesome to explain with a general physics or the physics without relativity, actually it was an improbable talk. So further, this redshift was explained with the help of the general relativity, and it was said that redshift was not due to the physical motion, but rather to light escaping on a deep gravitational wave that is known as a gravitational lensing. As we all know that, like when light passes to any very very deep and dense region of the space time, the light actually basically bends, and that is what we call gravitational lensing. So the whole redshift which we were getting, it was not because of any kind of physical motion, or it is some or something any abstract idea. It was just because of the gravitational lensing, and this was the ultimate proof of the brightness and the mightiness of general relativity. You can understand that how well the general relativity can be used to all these cosmological problems to understand, and that is how we can understand that all these redshifts was observed because of the gravitational lensing, not any kind of physical motion. So if anybody having this doubt on the gravitational lensing, I will further go in detail how this gravitational lensing is in WhatsApp talk or somewhere, something like that. Since I don't have much time right now, so I'm not focusing much on it now. So, however, the further observational evidence also came from 987 galaxies. So, as you know that we described the image of the black holes became from the center of this 87 galaxy. So, further they found that there was a black hole at the center of this 87 galaxy, and this quasar and this bright dot I was talking previously in my old talk, that the optical counterpart of these quasars were something as a teeny, very tiny, very bright dot. So they found that there was the galaxy at the center of this M87. So there was a black hole at the center of this M87 galaxy, and at the same point there was this black hole also is there, and you can see the image. This image is both. It's for both purpose. You can see the image. This was basically captured, and if you get the pornograph image of this, you will find the black hole at the center and the dot image, very bright image around it. That is basically quasars, and the observational evidence also came. So something you will see something like this. I'm going to previous slide here. So this is something where what is black hole is, and the disk around the black hole is what we call as a quasars, and that is what is liberating lot amount of energy, and this is some other object. So that was the observational evidence which we found for the idea of the Quasar engines. So now I hope everybody is clear with the idea of the Quasar engines. So I'm moving to next slide, that is the implications of this Quasar engines. Quasar. So what is the role this Quasar had to play? So Quasar is as I told that Quasar is a very important things to understand the evolution of this galaxy, or is the understand how we evolve. Again, Google was talking about the philosophy in the science, so I will understand that the only philosophy I would like to mention here, we should try to understand physics, because we should try to understand our own origin, because we know that we all started from stardust, and the stardust started from something about stellar nebula or dust or something like that. So what led this stellar dust to form into star? What led this nebula to form into star? That role was played by the quasars. So in order to understand our own origin, our own beginning, we should understand quasars. That is the philosophy I would like to give here. So quasar roles in the star formation. So influence the galaxy. Now, if there is a quasar and the black hole present inside in between any galaxy, how it is gonna influence the galaxy in which it is present, or I would say how it is gonna influence its host galaxy. So it can influence its host galaxy in three main ways: that through its jets, through wind of particle that manage to stream away from a certain disk, and through radiation from the certain disk. So if you ask me why these jets are created, and why this these winds are created, I will simply say I don't know. As one of my famous professor used this line, I don't know, go and find yourself. But however, I will say this how this jet. So you can see here this there is a stream jet which is coming out from this galaxy. Actually, Google suggested me a better picture which I forgot to add. I will send you the further in the WhatsApp group. You can all see that. So you can see this line coming out. This line on the both side, that is basically jet, or you can see this. These are the jet, and they are formed because when the gaseous particles are revolving around this black hole, they get highly magnetized, and if they get highly when the gaseous particles are revolving around this, they get ionized, and we all know that since the ionization of the particle, the movement of charge creates a magnetic field. When this ionized gas revolve at a very high speed, they get highly magnetized and create a lot of magnetic field. Now, when this magnetic stream magnetic fields are created, this magnetic field is twisted with the pull of the black hole which is present at the center. So we all know that there is a black hole at the center. So the magnetic field which is being created by the gas, they get pulled and twisted. And because of this pulling and twisting of this magnetic field, they come out in the vertical direction from the this black hole planes, and they end up into jets. So this jet is a very common phenomena around the quasars, and through winds of particle that. And again, we all know that if suppose you take the example of the fan, there is air molecules which is revolving around the fan, and it is creating a wind, right? It's creating kind of wind and flow. Suppose if something same kind of gaseous particle or stellar dust is revolving at a very high speed, what will create a lot of wind, right? It will create a lot of wind of particles, and that somehow managed to stream away from the certain disk, and that is also very accepted phenomenon. And then again, through radiation from the certain disk, as I told that there is a continuous radiation from this certain disk, so that also influences the galaxy in which it goes. Now I'm gonna question you how this is gonna affect. So all three can either promote star formation by compressing the surrounding gas and dust, or instead suppress star formation by heating the surrounding gas. And so if you go and figure out what is the first thing in the star formation, the first thing is that in the star formation is lot of stellar gas and stellar object is compressed into very small region that create a very huge gravity, and they keep on attracting all this nebula. So I will talk about this star formation later on if I get time today, or otherwise in some next talk. So they can be the initiating, that they can be the triggering point. So here I was talking about the triggering point for the star formation. So these jets, these winds, this radiation can be triggering point for the star formation by compressing the stellar dust. But it's not that they will always compress. Sometimes they can suppress by heating. They can suppress. They can just work opposite to the compression. They can, they will heat the gases or stellar dust so much that what will happen? As we know that when something will get heated, it will expand. And so if this nebula or the stellar dust get heated, they will expand and they will not let the formation of the star. So it still is the matter of great curiosity for the scientists, and it's a matter of great research that what lead this suppression and what lead this compression, which is still under the research. But as of now, we know that the triggering point for this star formation is nothing but quasars, right? So this is, I think I made this very clear. So as I told that the fuel for the black hole in the center of galaxy is not unlimited. It's a limited. It's not something that that certain black holes can keep on annihilating or attracting stellar dust from its surrounding for an infinite amount of time. It is limited because this quasars, which is basically a disk, of the black hole, will have maximum limit, because ultimate fate of that stellar dust which is revolving around the black hole is that they are gonna fall into black hole. Means they are gonna die, and so it's something limited. They were more possible. So what does that imply? So I am giving you two, uh, two graphs here. So the one graph is telling about the relative number of quasars and time frame, that is in billions of years. So we can figure out that initially there were lot number of the quasars, and with a time, as stellar dust and the fuel for the this quasars keep on decreasing, the number of quasars also keep on decreasing, because the fuel what basically was driving this quasar got exhausted, and the number of quasars also decreased. So as you can see from the graph. But what is very interesting for us, see, number of quasars is directly linked with the number of star formation. So these are the two countering graph. So in the another graph, you see when the number of the quasars were high, more number of stars are getting formed. As number of quasars got low, less number of the stars were formed. So this idea, this image, this number validate my previous theory that this quasars basically influence, or you can say that quasars are the basic trigger point for the star formation. So this I hope this is very clear that how the quasars play a very important role in the star formation. So again, quasar is very interesting to us because it deals how we started. Obviously, if there was no star, there was no human life, there was no life at all, there was nothing, there was no solar system. So quasar is very important to understand because it deals how this star formation begins. This point is nothing but matter in the system that I'm talking. Matter in the system is continually being depleted by falling to the black hole or being blown out from the galaxy in the form of jets. Then the quasars can continue to radiate only as long as new gas is available to clean the system disk. As I told this, the disk need to replenish. Since there is not enough matter to replenish this idea, this disk, so at a time the quasar will die. That's why the number of quasars with the time, with the evolution of the galaxy, so it got declining. As of now, I don't have exact data, but scientists have successfully located some 762 quasars only. So you can see that quasar is something which is getting extinct with the time. So we have very less time left to understand these quasars, and I will also understand. I will also make you understand what they tells us why they are important in another way. I told you that quasars are very important to understand the star formation, but they are also very important to understand the early universe. Early universe in the sense the universe which was much at when newly formed universe. So how they form it, like I will tell you that in next slide. So there is one good puzzle ahead. So my question is, what came first, black hole or galaxy? So I can't ask you because it is one-way communication as of now. But I will give you two scenarios which I talked about in my talk throughout. So as I told that this whole star formation, this galaxy formation is being mostly controlled by quasars, because quasar is the turning point, and this is what exactly this data shows. So the number of quasars is actually proportional to the number of stars, right? So this quasars lead to the formation of the stars, and as quasar, if I'm saying quasar lead the formation of the star, it means that black holes, because quasar is nothing but the disk of the black hole. In a layman term, quasar is nothing but the disk of the black hole. So I will say this black hole lead to the formation of the stars, because if there is no black hole, there is no disk. If there is no disk, there is no stars. So, but again, there is one contradictory point, that as I was talking at the very beginning, that as of our understanding, this whole black hole is formed from the stars. As I told, right, at the last state, that is the neutron star. Neutron star, after the neutron star, it gets compressed into very small amount, and that lead to the formation of the for the that star ends up into forming a black hole, as of our general notion says. But again, I'm saying that is my two. These are two contradictory. I am saying that quasars or black hole is required for the star formation. But again, I am saying that black holes can't be formed without stars. So what is true? What came first? The one must have to come first. Either black hole, which led to the formation of the whole galaxy and whole star, or the stars, which led to the formation of the whole black hole. So this is a very good puzzle you can think on. We can discuss it in the group. However, I have an answer of this, but this I'm leaving for the discussion. We will keep on discussing about this in the group later on. I have one idea and one answer, but that answer is not successfully yet proven or successfully accepted by every scientific community. It's just idea, and we will talk about it later on. This is a very good puzzle to think on. So again, this is probably my last slide, and I am already 8 minutes late. So understanding the universe through Quasars, again, how we can understand early universe through Quasars. So that is again, and that's why we are more interested in Quasars. So as I told you that there are very less number of Quasars left right now. There are some 735 or 760 Quasars are left right now. And now, so these Quasars are come with two things. First, they are very, very, very old objects. They are objects which are from the early universe. They are not like it was, as I told that initially there were a lot number of Quasars. With the evolution of time, the number of Quasars are declining, and finally it's left to some 700 or 800 or less than 1,000. So we can understand the and these Quasars are from very previous era or from a very early universe. And what does that imply? Quasars are a distant plasma revealing the properties of the early universe. Now I'm saying that if some object which is from much more behind, like much more years ago. So how that is important? So is to explain that I will take the example. So we all know that we are seeing Quasars we are seeing or studying this Quasar object from the radio signals and the optical images or optical spectra which we are receiving back at the Earth, right? So if I take this sunlight, so sunlight technically takes 8 minutes to reach from us. So on approximately 8 to 9 minutes. So sunlight takes 8 to 9 minutes to reach from its source to us. So if I am seeing the sunlight now, it means that I am seeing sunlight. I am looking at 8 minutes in pass to the sun, right? Since sunlight is taking 8 minutes to reach us, it means if I am in my frame, if I am seeing the sunlight, so but actually what I am doing, I am looking the sun in 8 minutes past. So similarly, since these objects are at a very distance and they had formed at a very early part, so they are very far distance. As we know that the universe is expanding, so due to expansion, their recessional velocity and all these things, there are Quasars which are discovered at a very furthest point. In fact, these Quasars are one of the most furthest discovered objects. So they are Quasars which are discovered at a very object. So light coming from Quasar to us takes some more than 2 billion to 3 billion to 4 billions of time. So it takes a lot amount of 3 billion to 4 billion light years, I'm saying. So it is the distance of time is like from 2 billion to 4 billion of years. It is very long time actually light takes coming from the Quasars to us. So if I am analyzing the radio waves or whatever optical waves are now, it means I am looking at the past of some 2 billion, 3 billion or more than that. So it means that I am looking at the universe. You see, since I am saying that, please try to understand, this Quasar is not something of the recent time. They are once formed and they keep on declining. As I told that there is a exponential decline in the graph, right? So they were once formed, they keep on declining. So The quasars were mostly expected to form like previous, like during the formation of universe, and light, the signals which we are receiving from it, something of the very early universe. So if we are analyzing the light or the radio signals coming out of the quasar, it means that it is coming of very, very, very ancient time. So astronomer now what did? Astronomer utilized this idea and they tried to understand. Astronomer have learned that almost all the hydrogen gas in the early universe are ionized into proton and free electron within a billions year after a Big Bang. So what happened? Now we were after we were, as I told, if I am receiving a pulse signals from the pulsars, now it means I am receiving a signal from billions of years back in the past. So when the scientists did the analysis of these signals which were received, they found that at earlier time, at the previous time, most of the gases, most of the hydrogen gases were into ionized parts. They were ionized. So what does this ionized in the sense? They were not as a hydrogen S or hydrogen atom. They were into proton and electron. So and that happens after billions years of the Big Bang. So now again, it is a very interesting and very data, because when we combine this data, this line data from the ACN, from another data which we are getting, that is from the anisotropy probe, that mapping microwave mapping of the universe. If you compare this to data, you will find that there was some 135 million years of blank. It means that once the Big Bang happened, then there was nothing between 135 million. There was nothing in the sense, like there was no ionization of the gas. Sorry, I put a wrong word. Nothing implies a lot of things actually in physics. So I will say that after the Big Bang happened, until 135 millions, there was no ionization happened, and suddenly we found the ionization parts. So which make us question what triggered this ionization, what basically lit this ionization, or what lit this universe. So in order to find this proper answer to, we have to understand the things which is much beyond the quasars, or which is much more older than quasars. And as of now, we hadn't found any such object. What we are finding, we are just finding the older and older version of the quasars. So again, this quasar is very important to understand in the this about early universe, because they are sending a signals very from a very past, and that signals is being received, and we have very less amount of time to understand that also. So we have to also keep in mind. Another thing, another application of this quasars is that mapping the filamentary matter structure of the universe. Again, as I told, that these quasars are sending a signal to us from very previous or very ancient time, so they can help us to tell that what were the filamentary matter structures. What different, as I told, that the spectral line is a very important tool for us. So every matter structure will have a particular set of spectral line. So if we keep on analyzing, and we can finally figure out that what is the structure of this thing. So I think I have it. Sorry, I don't have any more time to list. So I will not dealing with the pulsars and formation of stars as of now in this talk. I will take another talk on the same line of scale, and where I will deal about the pulsars as well as the formation of stars. So with this basic idea, so let me recall what we studied till now. So we studied what are the quasars, and what is the observation which we made, and then we developed a proper theory, that is a Quasar engine, to explain the observation, and then we imply the information to understand what triggered the formation of stars, and then also we try to understand the universe through quasars and different aspects.